Okay, so perhaps foolishly I signed up to give a short 10-minute talk here, and so I had to come up with stuff to talk about. So I just call this Lars' Random Topics. That's me, blah, blah, blah. So I work on HBase. I also have a black belt in Aikido, if you want to talk about that, or we can talk about Buddhism, or we can talk about the automating oil refineries afterwards. So lots of stuff we can talk about. But let's talk about HBase, right? So a quick reminder of what we're doing at Salesforce. We're doing right now, we're running 70-odd clusters, hopefully shrinking into fewer and larger clusters. We're doing about 5 billion end user Phoenix transactions per day. We're ingesting about 200 terabytes a day into HBase, and every single use case up to this time that's using HBase is actually going through Phoenix. And where are we with HBase, right? So we heard from Misty and from Josh that I did the same thing. So I went into Jira and I looked at, okay, when was the first Jira file? And it turns out that was February 27th, 2007. That's 11 years ago, right? We have over 20,000 Jira since, and the rate is going up, not down, right? Whether it's a good thing or not is a different discussion, but the same with Phoenix. The first Jira was created January 14th, 2014, so I'm not quite sure what happened before that, but and we have almost 5,000 Jira since. So we're 11 and 4 years in, and this thing is still growing. Who would have thought, right? We're still having conferences about this, right? And it's being used. It's, it's going into Asia now. It's a pretty phenomenal thing, I think. So we're still growing, right? So let's keep the hair growing and to do this for a few more years. So then, what about the future, right? And so now I'm just going to throw some controversial stuff at you, right? And so we get a discussion maybe afterwards, right? So this is the past, a little bit, right? Sorry. And so what do I think it's important? And those are my thoughts, not necessarily Salesforce. These are my thoughts, right? So the most important thing I think we get to do is to disaggregate storage from compute. We have the old ways where we the current ways where we run the region servers on the same machines where the data nodes run. With modern networks, it's not important. The data locality doesn't matter, only cache locality matters, right? So that's the first thing. Can we get rid of this HDFS monster and run it over something more modern, right? So that to me is a big question that's on my mind. Can we pull then the replication that the HDFS is doing one level up and put it into HBase and get not only data availability from it, but also compute availability? Can we do RAF at the HBase level instead of the 3 copies at the HBase level? What about the cloud? Why does HBase have no helping scripts or very little help to run it on Kubernetes, to run it in AWS, to run it on GCP? This should ship with HBase ready-made, I think. And why is Spark the ugly stepchild for HBase, right? We have support, but it's already using the outdated APIs as we speak. It's not as nicely supported as as MapReduce. And then last but not least, my general plea to everybody, and I tell that all my my friends at work, also, let's step back and think about distributed systems. It is a distributed system, and with everything we do, we have to keep this in mind, right? And I have a good example of one thing where we didn't do that. So I can actually look at this one, that's better. So just to state the obvious, the HBase and Phoenix are compute. Why do we have to run it together with HDFS on the same boxes with modern networks that will be 100 gig E soon? It's really no longer necessary. What matters is the cache. Can we run why does HDFS not have an S3 layer so we can run HBase over S3 over HDFS and then switch the storage out, right? Run it over Ceph, or just straight in over S3 in the same way, without any changes. The HBase already supports that, at least for the H files. The write-ahead logs still has to go onto HDFS because it's random small writes. Do we need to use HDFS there? Why can't we use Bookkeeper? Something like that, right? So I'm not saying we should do this. I'm just see whether we can get a discussion going afterwards, right? And why is HBase so hard to run? And that's in part HBase and the part Zookeeper. For the biggest part is this HDFS nonsense with the quorum journals, and it's not fun to run. It scales well, but it's not fun to run. So what about Spark, right? So why are we not supporting Spark just like we do the MapReduce, right? I think that's a very important thing that we have to pick up as a community at the same level, using the newest data set and data frame APIs. I think Phoenix is slightly better than HBase. When are we using Phoenix? When are we using Spark SQL? And on that, why does Phoenix not have a lower layer where it actually has a relational algebra API that Spark could use to access HBase, that then Spark could use, that Drill could use, that Presto could use, that Impala could use, right? So that should be the path into HBase with proper property predicate push down, sorry. Right? So I think Phoenix needs to have that. It's a nice project somebody should work on. Now, so you remember CAP, right? Distributed system CAP. Right? So there's a CAP. Let's remember the CAP. You all know this, right? Out of consistency, partition tolerance, and availability, you get to pick two, right? It's we all know what that means. The usual interpretation is this: if shit happens, and notice the nice brown of the shit there. So if shit happens, right, then you get to choose between consistency and availability, right? So all we do is we design all of our systems to be either consistent or of good latency, right? Now, but it's actually not CAP is a very small part of the design space only, right? So there's very many other reasons to have outages, right? Maybe even if you do everything right with with Raft and so you have n-half plus one of all your replicas up, it might be too slow, and like your end user case is no longer up and running, right? So it's actually not that simple. What if you cut your clients off from every single server? It doesn't matter how stable your server is, right? We really have to step back, think about why is P even an issue, right? And CAP is a very small part of the design space only, right? And so, dude, what does it really mean? So let's take an example, right? Let's say, I'm not blaming anybody here. This is just one example where we didn't think about distributed systems ahead of time, and take the first version of Phoenix mutable indexes, right? So we designed them to be always consistent, to always work, right? And the way they work is that one region server cross-writes their changes to another region server, which means they have to be partition tolerant, right? So even on the onset, it should have been clear this could have never ever worked, right? And so then we had this mad scramble, at least at Salesforce, but now we started to fix things, right? Okay, can we disable the index? So then it's no longer always available. Can we let it run, but not show us all the latest data? Then it's not consistent, right? But it was added later in a fairly ad hoc way, and it's a terrible hack now, in my humble opinion. And it came from us not thinking about CAP ahead of time, right? So even though I just said that CAP is bullshit, I mean, we should have thought about CAP when we did it, right? So the path out is I think the Omid guy is here somewhere, is the global client-driven transactional indexes, that's the way out. There are still times when they are not available, but that system at least is understood. The second way out might be local indexes, which actually works quite well. All the updates are machine local, right? So we're all clear, right? Not so fast either there. So because the indexes are local, you have to ask every single region, do you have it? Do you have it? Do you have it? Right? So now, as the number of regions is growing, the likelihood of you hitting a region that is moving, or it's down, or has some other issues goes up, right? And so we're trading our availability here, right? And so one thing we put into Phoenix is to help with this a little bit is region pruning, where we look at the prefix of the does the query use a prefix of the primary key, and if so, we can actually pre-prune the regions. That would make this a little better, but it's not a slam dunk. There is no slam dunk answer. Okay, so that was and so now comes the controversial thing. It's not just a software problem, right? And I will quote Eric Brewer here, who says that you look at Spanner. Theoretically, it's not a CA system. Practically, it is, because they design all their hardware, everything such that P is never an issue, almost never an issue, less an issue than bugs, right? And I mean, it's too small to read, but what it actually says here is that they control the hardware as well, and the software. They design it all together, and that's how they can essentially build, for all practical purposes, a CA system, right? So we have to do the same thing too. We cannot just solve it with software. It needs to be together with how we build our data centers, how we work with the cloud vendors, and so on to have a holistic view over the network and the software to really build CA systems that are always up and consistent. And I leave you with this. This is the most controversial thing I will say today. It's also the last thing I want to say. It's like, it's the problem on networking stack, right? Is it the OSI stuff? Is it the TCP, RPC? We all know that RPC kind of sucks. Is it the point-to-point stuff? How do we get the alternate routing working if routers are down, and so on? And so we need to step back and think about these things together and stop using CAP as an excuse to build bad software. Okay, that's it. Thank you.